Good afternoon, guys. Today I'm going to go over a little bit of the moon and Mercury as the second last section before the exam on Cratered words. Just a few facts about the moon and Mercury. So you can use it for the quiz on this chapter, and later with chapter 10, which we will talk about Venus and Mars, there will be an exam number 2. So the schedule for this will be, so let me share my screen right now very quickly. Here. All right, so the schedule should be a quiz at the beginning of next week for the moon and Mercury, and the exam at the end of next week, exam number 2, or maybe the beginning of the following week, which is the 16th, 17th. The idea is just to get you guys ready, all right, because we have some days off during Thanksgiving, all right? So after exam number 2, there is just a few chapters about the Jovian planets, the Galilean moons, and there will be a chapter about asteroids and comets, all right? Those are the 3 last chapters, pretty much, the 3 last topics. So just to talk to you guys a little bit about the moon, remember that the rise and fall of the tides on the Earth are caused due to the gravitational interaction between the Earth and the moon, are caused by the moon, pretty much, right? On the slides, and I will show you that later, they show you 2 bulges in the Earth due to the gravitational pull between the moon and the Earth. One on one side facing the moon, and on the other one opposite side that faces away from the moon, right? So you remember that the moon and the Earth are gravitationally synchronized. So the moon goes around the Earth in a period of 29 days approximately, right? A month. That's also the period of rotation of the moon, right? Due to this gravitational interaction, the moon is actually drifting away from the Earth. The moon is approximately moving 3.8 centimeters away per year. It's also important to notice that these tidal forces, right, they produce or they help with the ocean currents, which at the same way cause some sort of friction to slow down the rotation of the Earth, right? So that's important there. So it's estimated that as the moon drifts away from the Earth, that it will continue to do so for approximately the next 50 billion years. But by studying the evolution of the solar system and the evolution of the sun itself, we might not even get to that point. So you know about the missions to the moon, Apollo 11 to Apollo 17, right? The moon has been walked by 12 people, all American males. The moon doesn't have any atmosphere, all right? Just to see a comparison there, so you can see that the Earth to the moon in terms of scale is around 10 times larger, right? If we look at that picture there. And then there are some properties here. It has a considerably nice eccentricity of 0.0549. It has a mass around 100 times less than the mass of the Earth. So that's not actually too low, right? The mass of the Earth is 6 and 10 to 24 kilograms. And there you are, 10%, 1%, right? If you say in terms of percentage, it sounds much less, but in terms of astronomical sense, right? It's just 100 times lower than the mass of the Earth, considering that it's a moon and considering the difference between the masses of Jupiter and its moons, then we can see that it's actually not a big difference. It's important to notice this. The average temperature, surface temperature during the day and night, there is a big shift and quite a big difference to what we find here on Earth. And as I mentioned in the previous chapter, that's due to the fact that the Earth has an atmosphere and a greenhouse effect due to greenhouse gases like carbon dioxide and carbon monoxide. However, the moon does not have an atmosphere, which means that that's what happens, right? Also means that the surface of the moon is totally unprotected in comparison with the Earth, right? When there's a meteorite approaching the Earth, it gets disintegrated due to the friction, right, with the atmosphere, and in many cases, it doesn't get to land on Earth. So the moon is unprotected to that, but it's also unprotected from cosmic rays and solar winds, right? So the lack of atmosphere means lack of air. That means no sound can be heard on the moon, right? And the sky is always black, no blurry like in our case, because we have the atmosphere, as you know, when you go outside, right? So it's totally black, but be careful because that's one of the misconceptions, right? The reason why in the pictures from the moon, we don't see many stars, or we basically don't see stars, is because of the fact that the exposure period for the pictures was very low, plus the brightness of the equipment and the moon itself. The moon reflects light from the sun. So if you are using a camera with a photographic film in the 70s, 60s, right, then you will not be able to capture stars in the night sky. It will be as difficult as try to do it here on Earth, right? That doesn't mean that there are no stars or that the missions to the moons were fake. No, it's just that that's how light and exposure time works for a camera, especially back in the 70s and 60s, right? And 80s. So we have here a few properties. When we look at the moon, we can see craters due to meteorites crashing onto the moon, the Maraya, that we're going to explain in a little bit, and some light-colored lunar highlands, right? That's the near side of the moon, the side that we can always observe. And then we have also the dark side of the moon, which is, well, going to be in a bit, but normally the difference is the amount of craters, right? So what can we say about the Maraya? Before we talk about that, let's talk about how craters are produced. So this is a nice picture there. You have a meteorite approaching the lunar surface. It crashes onto the surface, and then you have compressed rock inside the crater and material being ejected. So depending on the speed and the size, some of that material can create secondary craters. You have a peak being produced there, and in some cases, you can have some lava in the interior flowing to the surface. That's why you have sometimes these rivers that once were filled with flowing lava. Now you're probably wondering, but what about now? I mean, there is no lava on the moon, right? It's because, and I'm gonna show you that in the next few slides, the rate of bombardment of meteors onto the moon has changed a lot. There are two periods of heavy bombardment. In the last 3 to 4 billion years, there hasn't been much bombardment of meteors. And that's very easy to explain. If you remember when we talk about the formation of the planets due to planetesimals accreting, right? There were still some very small remains, planetesimals, in the solar neighborhood, right? Between Mercury and Mars. And most likely some of them were meteorites that crashed onto the Earth and the moon. You also have to remember how water was produced on Earth due to the bombardment of icy objects that we know they are comets from the Oort cloud and the Kuiper belt. And since the moon is not too small, a lot of those comets or meteorites were deflected towards the moon, and that's why you have a lot of craters in there, right? So there is always an explanation for everything we observe, guys. So you have there the near and the far side of the moon. The main difference is the absence of marayas or mares and the more abundant craters, right? So we all know I want to send you guys a video about the exploration of the moon, Apollo 11, Apollo 12, Apollo 13, which was a failed mission. They were only able to orbit the moon. And then obviously we have to talk about Apollo, well, You can watch the video for Apollo 16 and 17. No Apollo 18, by the way, guys. All right. Despite of what some silly nonsense stuff is in the media. But let's talk about Maria or Mariah. That's a picture from Apollo 15 there, by the way. As we got more comfortable, guys, we were able to do more exploration on the moon, right? And the basic question of why we haven't been back to the moon is because there's no reason. There's no minerals. There is no enough money, especially nowadays. There's no motivation to go to the moon. Now you may be thinking, what about Mars? Well, the reason is because Mars is way farther. A motivation to go back to the moon will be to create a lunar base and use it to launch a mission to Mars, right? But so far, there is not really money / funding / motivation. Maybe if they had found minerals, right? Or things that we could extract from the moon that were worth going and coming back and spending those billions or trillions of dollars, maybe. Nowadays, the most relevant side of physics and astronomy is to explore the universe as a whole. Black holes, star formation, galaxies, the Big Bang theory. So we can do that from Earth without risking lives, right? But eventually we will be back to the moon and maybe use it to go to Mars, right? We're talking about 10 to 12 years from now. So we have some time to go, right? And especially with this stupid pandemic, we have spent too much money, guys. And that probably is going to affect the funding that we can use. Now, the moon doesn't have a magnetic field, but as you can see there, it has a molten core. It's just that it's not spinning. So you have a solid inner core, a molten core, so very similar to the Earth. And then you have a partially melt side of it. You have a mantle, and then you have, well, the mares and the crust. So what's a lunar Maria, a mare? It's a large, dark area on the surface of the moon formed by ancient volcanic eruptions when the moon was formed. And we're going to talk about that in a bit. They are less reflective than the lunar highlands, obviously, due to the rich iron composition of those. And hence they appear darker to the naked eye. Around 16 to 20% of the lunar surface are covered by Marias. So just on the near side, right? The few Maria on the far side, however, are much smaller, and they normally are very close to very large craters. So the traditional nomenclature for the moon, guys, however, includes oceans or mare tranquilities, where the Apollo 11 landed, as well as theaters named Lacus, lakes, Palus, March, and Sinus bays. The last three are smaller than Maria or mare, but have the same nature and characteristics. All right. Now, the moon also has earthquakes, by the way. We call them moonquakes. And moonquakes are produced due to the gravitational pull of the Earth. So how do we know that? Because we can bring seismographs to the moon, right? Like we do here on Earth. And we can monitor seismic waves that are or have an epicenter of a few kilometers beneath the surface of the moon, right? Just a few more information about the moon. The first spacecraft to reach the moon was Luna 1 in 1959, 10 years before Apollo 11 landed on the moon. This was a Soviet craft, which was launched from, obviously, the Soviet Union and passed around 6,000 kilometers from the surface of the moon. All right. Water on the moon, right? We have recently discovered water on the moon. So I would recommend you guys read this article from NASA Press so you can see why it's important, this discovery, right? And again, we didn't go to the moon for this. It was discovered by NASA SOFIA, which is sort of it's an infrared observatory that uses a plane, as you can see there, right? It's the NASA Stratospheric Observatory for Infrared Astronomy and has confirmed for the first time water on the sunlit surface of the moon. All right, so I will get you guys to read this article, and there's a nice video here, right? So it says that what was the Clavius crater, right? All right. So I expect you guys to watch that. I might ask you a few questions about that. Okay. So remember, no atmosphere for the moon, no gravitational, no magnetic fields, a molten core, however, right? The mare, the lunar highlands, the craters, the water on the moon, the missions to the moon. Oh yeah, in the slides they also give you the types of rocks that we brought back from the moon, several hundred kilograms, by the way. Yeah, by the way, here is like a slide explaining you the two positions of the moon and the gravitational interactions for the tides, all right? Look at the lunar geology. Lunar rocks reveal geologic history quite unlike that of Earth. But you know what? We have also discovered that the moon, the geology of the rocks of the moon is not very dissimilar to that of the Earth. Right? I mean, they don't have the same types of rocks. Like, you know, here on Earth, we have igneous, metamorphic, and sedimentary rocks, right? And we have the rock cycle. However, there are similarities. So that brings the question, right? There are similarities that we can find by exploring the surface of the moon, by doing geology. And I will add the fact that the moon has a molten core, right? So how come? And also, let's add the fact that the moon is quite big, right? It's 1% of the size of the Earth, but it's considerably bigger than the average natural satellite of a planet here in the solar system. So how come? Well, I want to give you guys a video for that, but I want to explain it to you. First of all, let's talk about the bombardments. As I was saying, there were two periods of early heavy bombardment that cratered the entirety of the moon. 4.5 billion years ago when the moon was formed, and then 4 billion years ago when the moon, 0.5 billion years after the moon was formed, right? But in the past 3.8 to 4 billion years, there hasn't been much bombarding, and look how it's decreasing, right? The line here is curved. The age of the moon brings a very interesting fact. The age of the moon is very, very close, almost identical to the age of the formation of the Earth, which is 4.5 billion years old as well, right? Now it makes sense, right? The formation, the solar system has 4.5 to 4.7 billion years, right? The sun, it's almost halfway through its lifetime. So how was the moon formed? What's the most accepted theory? Well, it's this one. We think, and there are models that we have done, there are computer-based models, that once the Earth was formed, about 4.5 billion years ago, a Mars-sized planetesimal collided, crashed with the Earth. And this makes a lot of sense, because remember, a lot of rocky materials which have a high melting point were wandering / orbiting around the solar neighborhood between Mercury and Mars. So it makes sense that one of those objects, big enough like Mars, was able to crash with the Earth. And this ejected a huge amount of material, as you are seeing there in the picture. And then this material was, well, around the Earth. And after millions or billions of millions of years, actually, that material accreted due to gravity into a spherical shape that we now know as the moon. Now, that will explain a lot of things about the size of the moon, the geology of the moon, and many other aspects of the moon, right? Now, it will also explain the tilt of the Earth, which is approximately 23 to 23.5 degrees. So because the Earth was not tilted all of a sudden, it had to be tilted by, in this case, a collision like that. Okay, so that is the accepted theory for the formation of the moon. All right, guys. Okay, and then to finish with this, let's talk a little bit about Mercury. So Mercury is also a cratered world like the moon, but has a surprising magnetic field. That's because it has an iron core, right? Cool and contracted, the surface of the planet, and makes it very ringed. All right, ringed. So Mercury has rings. So these scarps, as we call them in science, can be made up to a mile high and hundreds of miles long. First fact. Second fact, Mercury has a molten core and also an iron core. So we now know that this iron core of Mercury, right? Or sorry, in the recent years, it was when the NASA scientists came to believe that the solid iron core of Mercury could be molten. So what we know now is that that's the reason why Mercury has a surprising magnetic field. All right. Now, this core, we believe, has or contains lighter elements like sulfur, which will lower the melting temperature of the core material. So that's why we know that in the case of the core, right, that is what's producing the wrinkles, right? The iron core of the planet cools and contracts the surface of the planet. All right. Mercury's core is about 42% of its volume, while we remember the Earth core, well, we're talking about the volume for now, right? While the Earth core is around 17% of the volume of the Earth. Mercury is only the hottest planet. The hottest planet is actually Venus. And like many other planets that self-heal. So you should know that many planets, due to geological processes, they heal their surface, they reshape the surface. Mercury is covered by craters, all right? And just like the moon, this is caused by a number of encounters with meteorites, comets, and asteroids, all right? Only 2 spacecraft have visited Mercury, all right? Now, because of its proximity to the sun, Mercury is a very difficult planet to visit. But also, and you should remember this from the previous chapter, there it is, core, by the way. Mercury has a very high eccentricity. High, right? But the fact about Mercury's eccentricity says or tell us that it has the most elliptical orbit of at least the terrestrial planets. And it has what we know as the precession of the perihelion. The perihelion of Mercury, which is the shortest distance between Mercury and the sun, changes its position, each orbit. And that's only due or can only be explained when we introduce the equations of general relativity. So we can study the orbits of the planets around the sun and the moons and everything using Newton's laws. But we cannot predict certain aspects of them, like for example, in this case, the precession of Mercury's perihelion, by just using forces and the concepts of Newtonian gravity. we have to add gravitational interactions due to relativity, in this case, general relativity. And that is just because the idea behind general relativity is the fact that gravity bends space-time. So imagine the sun as a bowling ball on top of a couch. The closer you are, the more bent the couch is. So that's basically how it works. That's the simple explanation I can give you. Well, guys, I think that will be the best I can do, at least to summarize some of these ideas. I want you to look at the key ideas. There are always a lot, but the main part of this chapter was the moon and a few aspects of Mercury. Expect the next video in the next following days for Venus and Mars, and the quiz and the exam following those videos. Don't forget to do the Earth quiz, all right, guys? Have a nice rest of your day and have a nice weekend.